Have you ever wondered how the Earth, weighing up to 60 trillion tons, was measured in ancient times without any sophisticated instruments? Before answering this question, we first need to understand the shape of the Earth. As early as the 6th century BC, the ancient Greek mathematician Pythagoras proposed the concept that the Earth is a sphere, but this idea was strongly opposed by the proponents of the flat Earth theory. It wasn't until 1519 when Magellan and more than 200 people completed the first global sea voyage that the spherical shape of the Earth was finally proven. More than 100 years later, physicist Isaac Newton successfully discovered the law of universal gravitation, which states that any two objects attract each other. The gravitational force between them is directly proportional to the product of their masses and inversely proportional to the square of the distance between their centers. As long as the gravitational constant g could be obtained by directly measuring the gravitational force between two objects on the ground, the mass of the Earth could be calculated using the gravitational formula. However, because the gravitational force between objects is generally extremely small and difficult to measure, it troubled scientists for a long time. It wasn't until 1798 that British physicist Henry Cavendish solved this centuries-old problem. He suspended a lightweight wooden rod by a thin wire, attaching small lead balls to each end of the rod, creating a simple device. Cavendish then placed two larger metal balls near the smaller balls. The gravitational attraction between the metal balls and the small balls caused the wire to slightly twist. He fixed a small mirror to the wire to reflect a beam of light onto a ruler. In this way, even the slightest rotation of the wire would result in a noticeable movement of the light spot on the ruler. By knowing the length of the torsion arm, he could calculate the magnitude of the gravitational force. Using this unique method, Cavendish successfully calculated the mutual attraction between the two pairs of spheres. Then, based on the distance between their centers, the mass of each sphere, and the difference between the gravitational force experienced by these spheres and the gravitational force experienced by a similar sphere on the Earth's surface, he ultimately calculated the mass of the Earth to be 6.0 × 10⁻⁴ kilograms. Even when compared to modern measurements, Cavendish's calculated mass of the Earth had an error margin of only about 0.6%. This remarkable accuracy continues to amaze scientists, highlighting that human intelligence from centuries ago may have been far more powerful than we imagine.